Okay, so we just finished the pre-lab, or the lab, and now we're going into doing the procedure stuff.
What should the significant figure be?
So however many you had to start with in number 4.
Okay.
Okay, so we weighed our beaker. We added about 5 grams. You got a mass of the weight of the beaker and the still wool here. You're going to subtract these two to get just the mass of the still wool. That's what you put into the grid that I'm going to show you in just a second. You also should have had after right here, and you're going to take the mass after minus the beaker mass, so you can get the mass of just the oxidized iron. Okay? This is what we set up beforehand. Whatever you got in number 4 right here is what you're going to put right here on each A, B, C, and D. And then you should be able to put it in your calculator really quickly and get an answer right here. Okay? So I'll do that. I'm going to give you about 3 minutes to do that. If you have questions, let me know, and we'll talk about the analysis. So whatever you got for number 4, you're going to put in the front of A, B, C, and D and calculate it now. What you should have got. So whatever you got when you take away through number 3 minus number 1 in the procedure, you got an answer right here. That answer you need to start right here in A in the grid box that we set up before, or B and C and D, and calculate it through. Okay, you got to just calculate it through. You're going to take whatever you had in number 4, and it's going to start your grid that we set up last time in the pre-lab. That's the number you're going to start with, and you're going to just calculate through and find out the grams of FeO. Find out the grams of Fe2O3. Remember, times through the top, divide, parentheses, times through the bottom, close parentheses, get your answer. I gave you about 2-3 minutes to do that real fast. It should be quick. Should be quick.
So this number, is it 5.17 grams?
That you start with. Yep.
Okay.
Yep.
Like that, and then soften it?
Yes. So if I got 4.75, let me go back to where we had it, right here. So we set it up right here. That 4.75 would go right here. And we set this whole thing up, remember? And we just take that 4.75 and we times through the top, we divide parentheses, times through the bottom, close parentheses, get our answer. Then we put the 4.75 here on B, and we'd go through with B, times through the top, divide, parentheses, times through the bottom, close parentheses, get an answer. Do the same thing with C and D. Okay, we're just putting that number in that we didn't know, that mass of iron, and then we're calculating it through. Times through the top, divide, parentheses, times through the bottom, close the parentheses, get your answer. Same thing here. We've got that mass. We don't know which one we've got at this point. We're trying to figure out what mass should I have got at the end. Okay? Got about another minute and a half, and then I'm going to bring you back together and talk about the analysis.
So, right here, you're going to put 5.1 divided by this. And then do the same thing.
But you have to make sure that when you divide, you put in parentheses what you're multiplying on the bottom. Just to make sure that you get that.
Okay, got 1 minute left. We'll come back together. Okay, if you've got this done, make sure that you've gone over to number 11 and you've taken the mass of number 10 minus number 1 to get your mass that was oxidized. Okay, we're going to need that in this next part. We're going to need number 11, so make sure you've done the calculation for number 11. Okay, coming back together, your analysis here. The first question says, what is the most likely formula for your iron oxide from your data? Compare what you got in number 11 and your answers from number 5. So that's comparing these answers to what you got right here on number 11. Which one's closer? Which one of these that you just calculated is closest to what you actually ended up with in number 11? And you're going to put an X by which one you think it is. Okay? Then number 2. On number 2, it says if. Okay, I could have chosen B, C, A, D. I could have chosen any of them. I just chose C. So if the real formula was supposed to be C, we're going to do some calculations with it and see how far off we were. Okay, so the first one is if the real formula were C, use equation C. So I'm going to refer back to equation C for the rest of the analysis. I'm not going to look at A, B, or D, just C. Okay, and I want to calculate back to the weight, mass in grams, of the iron wool that would have been oxidized. So I take what I had in number 11. Start with whatever you had in number 11. Oh, come on. It's not going to write for me. Okay, so start with whatever you had in number 11. Sorry, this is not letting me write. I wonder if I stop it, if it'll let me write. Yes. Okay, so we're going to, it won't let me erase, though. That's nice. Okay, you're going to start with whatever you had in number 11. Okay, that's grams. And we think it's Fe3O4. Okay? Then on the bottom here, you're going to look at your table that you added up Fe3O4 from on the other side and put that mass there. That's how many grams are in 1 mole of Fe3O4. Okay? We can cross out grams of Fe3O4. Okay? Then, our next step is to look at that equation. What is the number in front of moles of Fe3O4 on equation C? That goes here. What's the moles in front of Fe? That goes here. Okay? That way we can now cross out moles of Fe2O3. And then the last step would be in 1 mole of Fe, we look up on the periodic table, 55.845 grams of Fe. Moles of Fe go out. Then I find the answer. Times through the top, divide, parentheses times through the bottom. Okay, get an answer. That's from this table right here. Right here, that number.
Oh, that's it.
Yep. The numbers are already added up. All we have to do is look at the front side. Fe3O4 should be already added up. Whatever it was when you added this up on the front side. Right here. Right here. You already added them up. So you don't have to add them up again. You just look at the front side. You've added them up. Okay? All right, on the next one, it says, although some iron is always lost and some is not oxidized, because we lost some because they sparks went everywhere, right? And some didn't get oxidized all the way. You didn't finish getting all of it oxidized because you still had big clumps. Okay? One way to look at what happened is to study the weight gain, because the weight gain is going to be your oxygen, right? So let's take procedure number 11 minus procedure number 4. That's our mass of our iron, of our oxygen. So number 11 minus number 4 gives us number 3. Would you do that? Okay.
Moles on the.
You're looking at this equation right here, equation C. So what's in front of this? 1. What's in front of that? 3. Okay, so on the next one here, use the weight gained, which is the mass of oxygen, from the analysis. So whatever you got for your grams of oxygen, you're going to put right here. You're going to make another little tree thing, or a factor label. And we're going to put here 1 mole of oxygen. And on the bottom, we're going to go 2 times the mass of oxygen That's just from the periodic table, right? Grams of oxygen can go out. So this is whatever you got on number 3. You put that to start. Okay, now I need to look at my equation C again. What's in front of O2? A 2. So 2 moles of O2. What am I trying to get to? Fe. What's in front of Fe? So we're still using equation C from the front. We're still using, so what's in front of mole of Fe? 2? 3? Okay, 3. And then moles of O2 will go out. So I'm just doing Stoke, guys. I'm just doing Stoke. Don't stress. And then 1 mole of Fe at the back and the mass of Fe. Okay, moles go out. Again, times to the top, divide, parentheses, times to the bottom. You got your answer. So now you're going to subtract procedure 4 from analysis 4, which we just did. And we're going to see how much really did react and how much didn't react. So this amount right here that you actually found right here, that's the amount of iron that actually reacted with the oxygen. The rest did not. Okay, so to get that, you're going to take whatever you got in procedure 4 on the front page, minus what you got here, and you're going to end up with an iron that didn't react. Everybody okay with that? Okay, and then we want to find out how much, what was our percent yield? Did we do a good job? Did we not do a good job? So our percent yield is taking our procedure number 11, that was right before we started the analysis, and dividing it by what we should have got, which was procedure 5C. That was from the table that we just did all those calculations. And then timesing it by 100, and we should end up with percent. Okay?
I'm totally just lost.
So this one right here, this was your answer from what you got here.
That's what I said.
That is where you're bringing that down. And then you're just converting it into moles and then converting it back to iron. So grams of iron.
Oh, is that right?
Yep.
Wait.
And then
So we
that.
So you just times across, divide, prints, times cost. Okay?
But what goes here first?
That, whatever your answer from here is. So you're going to take number 11 minus number 4. So 5.73 minus 5.06.
6.67.
That's how many grams of oxygen you got. And that's what starts up here.
I still got. Look at that.
Yep, it will be small. It will be small.
And where do we put that?
That's your answer to number 2.
Okay.
Okay, last thing we need to go over here. Okay, I want to make sure we're all on the same page here. Error analysis. What do you think? What could have gone wrong with this lab? Yeah, you could have lost some, right? There's some that's probably on the floor in there. When they go to mop, it's going to come up on there. Some probably went down the sink. Some probably went on your clothes. Okay. What about the oxygen? Do we have a constant supply of pure oxygen? No, you were blowing out CO2, right? With a little bit of oxygen. So we had some problems there. Okay, now we get to the part where we need to work with our claim. Okay, why did we do this lab? What was the purpose of this lab? Is there a purpose on the front?
To find out which of the oxides is formed by burning.
To find out which oxide is formed. So my claim is, what oxide do I think is formed? It's your analysis number 1. What did you think you formed? So you're going to say, I think whatever's formed. For evidence, you're going to show me the numbers that you got with the number you calculated, and then for justification, tie them together. Okay? All right. Have a great day. Make sure to upload this. Remember that you can redo any quizzes, assignments, or whatever until the 10th. The 10th is the deadline.